One, again, we're going through the SAGE math. I realize this is a problem that's typically done at the Calc 2 level where they introduce trigonometric substitutions, all right? So we went through it, excuse me. We also went through another technique, but the bottom line is we're talking about using SAGE now. So what I want to do is do something a little different over here. And I'm just going to, copy paste, all right? So I'm going to copy this over here, and we'll talk about where this is coming from and why we're doing it in a second. All right, so I'm going to copy paste. And where's this coming from? Let's go back to the notes and look at it. And it says, it says log, which means natural log in SAGE. Then I see the absolute value symbol. And then I see this quotient over here. And really what I'm witnessing is this over here. All right, I'm witnessing this over here. All right. I also want to put g of x down, and we'll talk about that as well. All right, we'll look back over. This is part of your learning curve, by the way. Type that in there. So what I'm going to do over here is go back, and I want to look, do I see this over here, the log of the absolute value? And I see that right over here. All right, let me go back to SAGE and show you that. So I'm seeing that g of x is the log, which means natural log, of the absolute value secant x plus tan x. All right, there's no constant of integration there. I don't need that. All right, so why don't you need that? Let's go back. I'm going to scroll over this again. I got this result over here. So someone says, what are you doing here? I did it two different ways, right? The first way I did it, which is the way they're typically taught in Calc 2, I got this answer, and then we used this new technique, and I got this one over here. The question is, are they the same? So what I want to do is I want to plot them. So I'm going to say S is a variable now, or a placeholder, and I want to plot PLOT. Now, if these are antiderivatives, they're either going to be equal or they're going to differ by a constant, all right? So what I want to do is, plot those two functions together. So I'm going to plot f of x, and I'm going to plot g of x. Now, this is a default. It may not give me the best picture, but probably the best I could come up with at this point. So someone says, could you display the S? And let me do that for you. I'm going to say S, and what I want to do is I want to show it. That's going to launch a graphic viewer. And, I'm looking at this thing over here. I'm wondering, are they really the same thing? And someone's going to say, I don't even see two graphs over there. Right? I'm going to go back and I'm going to plot one at a time now. So plot, PLOT. I'm going to plot f of x. That's only one of them. And I get that picture over there. All right? Well, I do see that. I'm also going to plot g, PLOT, g of x. Same picture. All right? I think you probably noticed that. Now, again, if you want to, you could play around with this, and I do recommend you play around with software. Let me go back over here, and I'm going to change x min, I don't know, to minus 10, and x max to 10. We've done this before. Whoops, I made a mistake there. You notice that? And I think I have too many parentheses. That happens sometimes. All right? You get the idea what's happening over here. So when we graph things out, we're using a default thing. They might only be graphing a region out. Now they're graphing a bunch of different things out. Now certainly I could go back and do f of x now. Let me go do that for you. This is just playing with software, and I recommend you do that. Getting same, I should say, I realize that some people said the artifacts in the picture aren't the same. It's really the same picture. What might be different is, the way it's graphing out the asymptotes over here. And again, there's things you could do, detect poles, things like that. But right now, you're just getting a feel for the software. All right, I want to go back. I'm going to close these pictures out here. I'm going to try one more thing that we've done before. And I'm going to try a Boolean. And the Boolean what I'm going to do is differentiate diff, f of x, and g of x. All right? Now, by the way, they should be the same. It says it's false. Now, I got to be honest with you. Some people say, I wonder why that could be. A couple of reasons why is, SAGE may not be able to detect that they're equal. They may not be able to detect their equal, may not be able to simplify it. It may be too complicated. I'm also going to try to see if they're equal, and I want to see what Sage says. So I'm going to do Boolean. Does g of x equal f of x? And again, my suspicion, it won't be able to do this either. There's a point to this thing. I made it too many parentheses over there. It says it's false again. What is it doing? It's looking at those things. It doesn't see that they're equal or that they differ by a constant. It's not really seeing it. All right. I'm also going to do integrate. And let me do a copy paste over here. And it does it. What does it return back to me? My favorite one, the one that we discuss in Calculus 2, at least at most schools this is done. That's my recollection in school as well, by the way. Thank you.